Let me try to get a thumbnail in. I think that's cute. Let's do it. Hey guys, welcome back to another video with Micro J, where we do all things microbiology. And today we're going to look at onion cells. So I have a yellow onion and a red onion. I'm going to start with the yellow onion. I have a knife here. I'm going to just cut a little square out so we can get a nice little sample of the onion. So when you cut the onion, you just want the epidermis layer. So that's like a real thin layer on the inside of the onion. Peel it slowly just so I don't rip it. Boom. And we got your epidermis. I'm putting it on the side. Just take a small drop of water, put it on so you can see. It might have been too much, but we can just wipe the excess off later. Put that to the side, get a cover slip, put that right on top, try to avoid any air bubbles. Drop. Boom. And I'm going to wipe the sides off. I'm going to put it on the microscope. Now I'm going to touch my phone. Bring it up. Boom. Just like that. Just like that. So they look like each of these little circles are the cell wall of each onion cell. And they're arranged like bricks, like a brick wall, like a brick road. Let's zoom in. I think each of those little round circles on the inside are the nuclei. I don't see anything moving, but I'm gonna zoom it in and out, see if we can see any other structures. But so far the yellow onion just looks like a brick. Like just bricks, arranged bricks, organized bricks. That's what it look like. So the yellow onion is real bricky. So that was pretty cool to see. Now I'm going to stain just so we can try to see any other structures. So the stain I'm going to use is EOS and Y. So EOS and Y stains, let me put my glasses on to make sure I read the directions clearly. Okay, I got my grandma glasses on. Got my instruction manual. EOS and Y stains red blood cells, cytoplasmic material, cell membranes, and extracellular structures in pink or red colors. I'm gonna open it. I got it on the first try. To cover it. Timer 15 minutes. So fun fact about onions. In the Middle Ages, onions were used as a currency. You can pay your bills with an onion. You can pay your horse note with an onion. You can pay for food with an onion. You can pay for food with another food. So it's been 3 minutes. I'm just going to rinse it off with water and then put it on a new microscope slide so we can see it. I'll put a glove on so I don't mess up my pretty hands. Ooh, it's nice and pretty. So what we stained for was, as we said earlier, cytoplasmic material. And it looked like the nucleus got stained also. The cell wall doesn't look like it got stained much. The cell wall still looks the same. But look at all these pretty pink circles. They still look like bricks, like a brick wall. Look all these here. So that was with the Eosin Y stain. I'm gonna try one more stain just to see if we can see something different. And the stain that I'm going to use is iodine. So iodine stain starch. Onions have a little bit of starch, so we're just gonna see if we can see something different. I'm gonna put a drop here. Ooh, so this time instead of pink, it's green. Let me go back to the 4X. Ooh. So it looks the same as before, like this little brick pattern, but this time the nucleus is kind of red, reddish orange, brownish color. And then it looks like the cell wall is a little bit brown. So that means there is some starch in the cell wall. That's what the iodine is staining for. But you can really see each of the nuclei in each cell. So it looks like it's one nuclei per cell, which makes sense. Yeah, that's pretty cool. I don't know if this triggers some, what's that phobia where you're like afraid of holes? So like you can look at holes in an arranged pattern like a beehive or like a honeycomb or like a, I don't know, but this looks pretty cool. So that was the yellow onion. Now we're gonna move on to the red onion. And same process, I'm gonna cut a little square and then pull the layer off, but I'm gonna pull the outside layer instead of the inner. Oh my gosh, y'all, look at this. Look how pretty this is. So pretty. Look at these cells. Look at these cells. Oh my goodness, they are so pretty. These are so pretty. This is the cutest purple. The cutest purple. Let me just get a clear spot for you. Then let's get in a little closer. So with the red onion compared to the yellow onion, the cell wall looks clear, but with the yellow onion the cell wall looks, so with the iodine it looked brown because of the starch in it, but without the stain the cell wall looked a little grayish, blackish, but in the red onion it looks completely clear. So that means the cytoplasm and everything is purple. That's so pretty. So I want to try something new with the red onion cells. So because they're purple, you're able to see what we're going to test out. So we're going to use the concept of osmosis. So osmosis is the spontaneous net movement of water. So what causes water to move is the concentration of solutes. So solutes is basically like dissolved particles. So for example, let's say you have a container, like a little beaker, and you have equal concentrations of solutes on each side, and you have a semi-permeable membrane in the middle. So if you have the same concentration of solutes on each side, the movement of water is the same for each side because you have equal amounts of solutes. However, if you have a higher concentration of solutes on one side, water will move to the side with the higher concentration. So you can think of it as, you know, so say the solutes is money and your water. You want to get to that money, right? So you're going to go to the side with the most money. So that's how water works. So if there's a side with a higher concentration of solute, water is going to go there. If there's a side with a higher concentration of that bag, you're going to go there. So that's how osmosis works. So some real life examples where osmosis occurs. You're in the bathtub. So you know, you're in the tub, you're minding your business, you're sipping your wine, you got your candles, you know what I'm saying, you with your dude or your girl, whatever, and you sit there for probably like 30 minutes and your skin get all pruny. That's osmosis. So what happens is water is going through the skin of your fingers and it's swelling your fingers to where your fingerprints are all big and pruny. So your skin is not shrinking, it's really swelling because all of the water is going through and your fingerprints look all old. Another example is what we're going to see here. It's with these red onion cells. So we're going to do 2 experiments, I guess. So I'm going to introduce these red onion cells to a high concentration of salt. So the salt is going to be the higher concentration of solute, and then I'm going to test it with just water. So what we should expect is once we add the high salt concentration to the cells will shrink, and that is because the water is leaving the cell. The water is leaving the cell to go to the higher concentration of solute, which is the salt. So the water is going to that bag, you know what I'm saying? The water is going to the bag, which is outside of the cell. That's where it wants to go. So here you can see that the cell membrane has shrunk and it's kind of like detaching from the cell wall. So all this purple is getting smaller and smaller and smaller. And that's because the water is leaving the cells to go towards the high salt concentration on the outside. So when we add water, the higher concentration of solute is inside of the cell. So the water is going to go from outside to inside of the cell. Solute concentration is higher, meaning there's more bags inside the cell. So where are we going to go? We're going to go inside the cell. And so that's going to cause the cell to swell up. So in this time-lapse video, you can see that the color of the onion cells are getting lighter and turning clear. So this is just a close-up. You can see the water going in and kind of diluting the cytoplasm of the cells, turning them white. So here's a closer look at the neighboring cells. So you can kind of see the nuclei bouncing around as the water moves in. And here's a closer look. You kind of see the black dots that are moving. Those are like the organelles or small vesicles that carry nutrients and everything around the cells. Alright, now my room smells like onions. I'm gonna have to burn a candle or incense or something. But thanks for watching. I hope you learned something new about cells and osmosis and how water moves through cells and everything. Please like, share, and subscribe. Let me know in the comments what you'd like to see next. And peace out. But definitely click somewhere to watch my previous videos, and stay safe out there. Wear your mask, wash your hands for 20 seconds, social distance. This is not a game. Corona is not a game. Please be safe out there, everyone.